Let us solve a numerical related to the Raoult's law. It is a numerical, it is an in-text question. In-text question number 2.8. It is related to our previous video. It is related to Raoult's law. So question is, it is in-text question. The question is, the vapor pressure of pure liquids A and B are 450 and 700 millimeter of mercury respectively at 350 Kelvin. So liquid component A and B, pure liquid A, for pure liquid A vapor pressure 450 millimeter of mercury, and for pure liquid B vapor pressure how many? 700 millimeter of mercury. So vapor pressure of a liquid depends on temperature, so temperature mentioned here 350 Kelvin, and the pressure here mentioned in which unit? Millimeter of mercury. Everybody know it, 1 atmosphere equal to 760 millimeter of mercury. So two pure liquids A and B. In our previous video we are considering liquid components are as 1 and 2, but in this question liquid components are considered as A and B. So for pure liquid A and pure liquid B vapor pressure are given in this question. So we have to calculate, find out the composition of the liquid mixture if total vapor pressure is 600 millimeter of mercury. जब कंपोनेंट A and B मिक्स कर दिया, दोनों लिक्विड कंपोनेंटों को मिक्स कर दिया, देन वी हैव ए लिक्विड मिक्सर, वी हैव ए सोल्यूशन. सो जब A and B मिक्स कर दिया, टोटल वेपर प्रेशर कितना हुआ मिक्सर का? 600 मिलीमीटर ऑफ मर्करी. सो हम लोग क्या फाइंड आउट करना है? हम लोग लिक्विड मिक्सर का कंपोजिशन, मतलब लिक्विड मिक्सर में कंपोनेंट A एंड कंपोनेंट B दोनों का मोल फ्रैक्शन फाइंड आउट करना है. और हम लोग फाइंड आउट करना ऑल्सो फाइंड द कंपोजिशन ऑफ द वेपर फेस. सो वेपर स्टेट में कंपोनेंट A एंड कंपोनेंट B का कितना कंपोजिशन है, ये भी हम लोग फाइंड आउट करना है इन दिस क्वेश्चन. सो क्वेश्चन इज रिलेटेड टू द राउल्ट्स लॉ. सो in this question vapor pressure for the pure component A is given. For the pure component vapor pressure is denoted by the not PA naught is how many? 450 millimeter of mercury, and vapor pressure for the pure component B how many? 700 millimeter of mercury. जब A and B दोनों मिक्स करके मिक्सर बना दिया, then total vapor pressure in the mixer how many? 600 millimeter of mercury. So these are the given quantity in the question. These are the given quantities. So from this given quantity, first of all we have to find out the composition of the liquid mixer. Composition means concentration. So now calculation of composition in the liquid mixer. That means we have to calculate now XA and XB. We have to calculate now. In our previous video we are considering XA as X1 and XB we are considering as X2. So to calculate the XA and XB, total vapor pressure P total is given. So according to our previous topic, P total vapor pressure of a liquid solution is equal to PA naught plus PB naught minus PA naught into XB. This is the relation we established in our previous video. But in previous video A are considered as 1 and B is considered as 2. So P total is given. P total is 600. PA not. So PA not given in this question is 450. PB not given here 700 minus 450. XB we have to calculate. XB and XA are the composition in the liquid phase. Mole fraction of component A and B in the liquid phase. So 600 450 हम लोग लेफ्ट साइड में लेके आ गया. 600 minus 450, 700 minus 450 equal to 250 into XB. So 600 minus 450 equal to how many? 150 equal to 250 into XB. So XB equal to 150 divided by 250. After the calculation it will 0.6. So composition of liquid component B in the liquid phase how many? 0.6. To calculate the XA we can apply this relation. XA plus XB always equal to 1. That means sum of the mole fractions of two components in a solution is equal to 1. So XA we have to calculate. So XA equal to 1 minus XB. So 1 minus XB equal to 0.6. So it is equal to how many? 0.4. So 0.4 is the composition of component A in the liquid phase. Now calculate the calculation of composition in the vapor phase. That means we have to calculate YA and YB. We have to calculate YA and YB are the composition in the vapor phase. So to calculate YA and YB, to calculate the composition in the vapor phase, relations are PA equal to YA into P total and PB equal to how many? YB into P total. So in the question P total is given, but PA and PB are not given. What is PA? Partial vapor pressure for the component A in the solution. What is PB? Partial vapor pressure for the component B in the solution. So PA and PB are not given in the question. So to calculate YA and YB, first of all we have to calculate PA and PB. So to to calculate PA and PB, we know that PA equal to PA not XA, then PA not equal to, given in the question, 450 millimeter of mercury. XA we have already calculated, then this is equal to 180 millimeter of mercury. Similarly PB equal to PB not XB. So PB how many here? PB not given in the question how many? 700, and XB already calculated, it is equal to 0.6. After the calculation it will 420 millimeter of mercury. Now we have to calculate YA and YB using this relation. So now PA equal to YA into P total. So YA equal to PA divided by P total. PA equal to 180, P total 600, then it is equal to 0.3. Similarly PB equal to YB into P total. So YB equal to PB divided by P total, then PB equal to 420, P total equal to 600, this is equal to 0.7. So this is the answer for this question. Let us solve one more question from the exercise. It is exercise number 2.16. It is from exercise. In this question, two liquids are, one liquid is heptane, which molecular formula C7H16, and another one liquid is octane. These are two hydrocarbon, molecular formula C8H18. Let us consider first liquid. Heptane is considered as liquid 1 and octane is considered as liquid 2. Let us consider. So in this question, for both pure liquid components, vapor pressure are given at 373 Kelvin. दोनों प्योर लिक्विड कंपोनेंट का वेपर प्रेशर दिया हुआ है. So vapor pressure for the pure liquid component 1 is given P1 naught, pure component, so not, we have to write P1 naught. Vapor pressure for the pure liquid component 1, that is heptane, is equal to 105.2 kilopascal. Pascal is the SI unit of pressure. And vapor pressure for the pure component 2, octane is considered as component 2, equal to how many? 46.8 kilopascal. According to question, by mixing these two component, these two liquid component, heptane and octane, prepare a binary solution. So here weight of component 1, how many gram of component 1 are mixing here? Component 1, weight of the component 1 is 26 gram and weight of the component 2 equal to how many gram? 35 gram. So 26 gram of A, 26 gram of component 1, liquid component 1 is mixing with 35 gram of liquid component 2. Then according to question, we have to calculate P total vapor pressure of the solution. We have to calculate according to the question. जब दोनों liquid component mix किया, then we have a solution. Then we have definite vapor pressure of this solution. So how many total vapor pressure of this mixture we have to calculate. So to calculate the total vapor pressure, this is the relation. P total equal to P1 naught plus P2 naught minus P1 naught into X2. So this is the relation to find out total vapor pressure of a mixture of two liquid solution. Mixture of a liquid solution, liquid solution. So P total, so this is the relation to find out P total. So to calculate the P total, P1 naught and P2 naught are given in the question. But X2 is not given in the question. What is X2? X2 is the mole fraction of component 2 in the solution. So to calculate the P total, first of all we have to calculate X2, that means mole fraction of component 2 in the solution. So to calculate the mole fraction of component 2 in the solution, first of all we have to calculate the number of moles of component 1 and 2 in the solution. So to calculate the number of mole fraction of component 2 in the solution, molecular mass of component 1 and 2 are also needed. Molecular mass of heptane equal to 100 gram and molecular mass of octane equal to how many? 114 gram. Number of moles of heptane is equal to its given mass in the question, its given mass 26 gram divided by its molar mass equal to 100, then after the calculation 0.26. Similarly, number of moles of octane, given mass of octane 35 gram, its molar mass given molar mass is 114 gram, then this is equal to 0.30 mole. These are in mole. Number of moles of heptane and octane in the liquid solution. Now mole fraction of heptane, which is considered as component 1, is equal to individual moles of it in the solution. This is the individual moles of heptane in the solution divided by total number of moles, 0.26 plus 0.30. So 0.26 divided by 0.56, after the calculation this is equal to 0.46. Similarly, mole fraction of octane, which is considered as component 2, equal to individual moles of octane divided by total number of moles, divided by total numbers of moles, then this is equal to 0.535. So mole fraction of heptane in the solution 0.46 and mole fraction of octane is equal to how many? 0.535. Now calculation of total vapor pressure of the mixer. Total vapor pressure of the mixer. So to calculate the total vapor pressure of the mixer, this is our relation: P total equal to P1 naught plus P2 naught minus P1 naught into X2. X2 mole fraction of component 2, mole fraction of octane in the solution. So P total we have to calculate. P1 naught given in the question, this is equal to 105.2. P2 naught, this is equal to how many? 46.8 minus P1 naught and X2, this is X2, 0.535. After the calculation it will be 73.956 kilopascal. So this is the answer of this question. In this question, mention about the ideal solution. What is the ideal solution? We will discuss in our next video. So thank you.